Welcome to The Deep Dive, the show that cuts through the noise and gets straight to the insights. You know that universal feeling when you're embarking on any significant project, right?
Oh, yeah, absolutely.
Maybe you're overseeing the renovation of your home, launching an ambitious new product at work, or even just planning a family road trip that needs to be just right. There's this constant, almost existential push and pull. You want it to be extraordinary, top-tier quality, perfectly tailored to your vision and needs. But then, inevitably, reality steps in, often in the form of a budget, a deadline, or a resource constraint.
It's always the budget.
Right. And suddenly, you're wrestling with this core question. Is it genuinely possible to get more for less? Or does every single cost-saving measure, every financial squeeze, inevitably mean compromising on the very quality or vision you started with? It's a tension that plays out in almost every decision we make.
It really is. And that tension you describe, it's not just a modern challenge, it's a truly fundamental dilemma. It shaped human endeavors and dictated the trajectory of countless projects for, well, millennia.
Millennia, wow.
Yeah, I mean, while we might employ sophisticated terms today like value engineering or optimization strategies to describe the process of calibrating function, cost, and quality, the underlying principles, they're as old as the first structure humanity ever tried to build. From the colossal pyramids of ancient Egypt to the enduring aqueducts of Rome, all the way to the glistening modern skyscrapers that touch the clouds. Every single builder, every pioneering engineer, every astute project manager has had to grapple with this exact same balancing act.
So it's timeless, really.
Precisely. Our deep dive today is exactly that. A journey across vastly different eras and projects, exploring how humanity has navigated this persistent tension. We're going to uncover some truly fascinating insights into what genuinely constitutes value. How it's not merely about the lowest price tag, but about profound choices. We'll examine how that value is achieved, sometimes through extraordinary ingenuity, and quite often how it's inadvertently undermined by short-sighted decisions.
Okay, let's unpack this fascinating historical and contemporary challenge then. We're going to look at how truly smart choices, incredibly clever design, and yes, even some hard-learned lessons from history illuminate this delicate and often frustrating balancing act. We're going to journey from the pragmatic wisdom of ancient Greece and Rome, move through the seismic shifts of the Industrial Revolution, and then bring ourselves right up to our current age of sophisticated digital project management and cutting-edge sustainable design. You might be genuinely surprised at just how much the past can tell us about our present-day challenges in building with both quality and economy.
I think you will be. There are some surprising connections.
So let's fire up the time machine, so to speak, and rewind the clock way back to the dawn of organized construction. When we picture ancient builders, our minds often conjure images of grand, almost impossibly expensive structures like the Parthenon or the Colosseum.
Right, the icons.
Exactly. But beneath that grandeur, what practical lessons can we genuinely learn from the Greeks and Romans about building effectively, about achieving enduring value, and perhaps even extracting more for less in ways we might not initially consider?
That's a fantastic starting point because these ancient civilizations were, in essence, uncredited masters of efficiency and intelligent resourcefulness. They were operating long before such concepts were formalized into, modern terminologies.
Right.
Take Greek architects, for instance. The sources, like lectures on architecture, note they were incredibly pragmatic. They had this keen awareness of both resources and labor. They were famously chary of scaffolding. And that phrase itself is quite telling, isn't it?
Chary, meaning cautious, reluctant.
Exactly. Extremely reluctant to use temporary support structures. Think of it like a meticulous craftsperson who dislikes buying single-use tools that just clutter the workspace and ultimately add no lasting worth.
Oh, okay. Right.
They viewed scaffolding as a significant and often useless labor and expense, a temporary measure that added no intrinsic value to the final permanent structure. So instead, they cleverly integrated construction support directly into the building itself, using carefully placed projections for timbers.
Wow. So not just building the thing, but building the support for the thing as part of the thing.
Precisely. It wasn't just about cutting immediate costs. It was about brilliant, integrated design. It made the construction process an inherent part of the final, enduring structure, minimizing waste and the need for expensive temporary works.
What a remarkable insight. It truly speaks to a deep, integrated understanding of the entire building process, one that goes far beyond just the final aesthetic. They were, in essence, thinking end-to-end about value long before we even coined the term.
Absolutely. Their ingenuity was profound. and it extended to the very core of structural integrity. Consider their solutions for lintels, those crucial horizontal beams that span between columns, right?
Yeah.
When working with calcareous stones like marble, beautiful stuff, but it could harbor invisible internal flaws or microfractures, hidden imperfections that might cause sudden irremediable fractures under immense strain. Catastrophic failure,
Yeah,
basically.
we can see it coming.
Exactly. So to mitigate this risk, the Greeks devised a remarkably clever strategy. Instead of fruitlessly searching for perfect, massive single blocks, which would have been prohibitively expensive and time-consuming, they would compose a lintel from two long stones placed side by side, leaving a vertical joint between them.
Two stones instead of one big one. How did that help?
Well, it offered a probabilistic advantage. The source says 2 chances to 1 in favor of resistance. If one stone had a hidden flaw that might lead to failure, its twin, placed right beside it, might still possess the necessary integrity to withstand the strain, preventing an immediate collapse.
Huh. It's like built-in redundancy almost, hedging their bets against hidden flaws.
Kind of, yeah. It was a sophisticated and incredibly intelligent way to ensure durability and safety without incurring the excessive cost and logistical nightmares of quarrying only flawless, oversized, single-piece blocks.
So they were designing with the material's inherent limitations firmly in mind, finding these brilliant, intelligent workarounds rather than simply trying to brute force a solution with sheer mass or unattainable perfection. That, right there, is a massive lesson in extracting maximum value, isn't it?
It's an absolute masterclass. And they also keenly understood how to avoid too great expense and difficulty by strategically using smaller blocks above the architraves.
Okay.
They intuitively grasped that if the material itself presented a defect in raw tensile strength, or if sourcing perfect monumental pieces was impractical, they could brilliantly compensate for that material limitation through sheer intelligence in design.
Intelligence over just bigger rocks.
Exactly. It highlights a truly fundamental principle that resonates across millennia. Value isn't just inherent in the material itself, it's in how you ingeniously use that material, how you understand its limitations and strengths, and how you design around them. It's about a master builder's creativity to coax maximum performance out of a given resource, rather than simply seeking the most expensive or perfect one.
That mindset shift is crucial. It tells us that even constrained budgets don't necessarily lead to compromised quality if intelligence and innovative application are prioritized.
Couldn't have said it better.
That's truly fascinating. And the Romans, then, known for their sheer ambition and scale. What enduring lessons did they impart about economy and durability in their monumental undertakings?
Ah, the Romans. In many ways, they took these Greek principles and scaled them to an entirely new, breathtaking level. They mastered the art of achieving incredibly lasting structures with what the sources describe as strict economy.
Strict economy on something like the Colosseum seems counterintuitive.
It does, but it's true, especially evident in their massive public works like the amphitheaters. These were structures explicitly designed to last forever, and many largely have. They did it by employing a revolutionary cellular system of construction.
Cellular system, what does that mean?
Imagine not building a solid monolithic block, but rather creating a sophisticated internal skeletal framework. This meant they erected and sustained enormous masses, not through sheer brute material, but by meticulously creating isolated points of support and walls, then unifying and bracing them with a succession of arches and vaults built one above another.
I can almost visualize that like a massive, incredibly robust honeycomb structure, rather than just a dense, solid block of stone. That explains how they could build so big so quickly, maybe.
Precisely. This structural efficiency was absolutely critical to their success. It meant that, for instance, the imposing exterior wall of an amphitheater had little but its own weight to carry. It acted merely as a decorative envelope rather than the primary load-bearing element.
So the fancy outer wall was mostly for show. The real work was happening inside.
In structural terms, yes. This brilliantly optimized material use, allowing for structures of immense scale and astonishing durability without requiring an impractical or economically unfeasible amount of solid masonry. You see evidence of this today in places like Verona, where the internal cellular structure of ancient amphitheaters still largely stands, even where the exterior walls have been almost entirely destroyed. Wow. That's a testament to value and economy in action for truly enduring, large-scale projects.
It's truly fascinating to see these ancient echoes in our modern challenges. Whether we're talking about Roman amphitheaters or the nuanced choices of Greek temples, the fundamental debate about smart spending versus simply cutting corners is, as you said, as old as civilization itself. And while the core problems might be ancient, Our tools and approaches to solving them have certainly evolved. But even in more recent history, during the industrial era, we see this same tension playing out with profound consequences.
Indeed. Let's fast forward to the Industrial Revolution and consider engineers like Isambard Kingdom Brunel. A titan, his name is synonymous with groundbreaking engineering.
Brunel, right, the bridges, the tunnels.
Exactly. His experience with the Thames Tunnel provides a stark and enduring cautionary tale about the dangers of short-sighted cost-cutting. His father, Mark Brunel, also a brilliant engineer, had initially proposed a crucial economy, building a driftway below the main tunnel.
A driftway, like a smaller pilot tunnel.
Essentially, yes. This smaller auxiliary tunnel was designed specifically to carry off water, a constant and immense problem when tunneling under a river like the Thames. This preventative measure, this upfront investment, would have considerably mitigated the subsequent catastrophic disasters and vastly improved the appallingly difficult and dangerous working conditions.
So an upfront investment to prevent much larger problems later, essentially. Why didn't they do it?
Tragically, the directors, fixated on immediate savings and minimizing initial capital outlay, refused this sagacious suggestion. The source says this economy was refused.
Oh, no.
And the consequence: far greater, prolonged, and ultimately more expensive long-term issues. Imagine the scene. Enormous volumes of water constantly breaching the tunnel, relentless trouble with bucket pumps, men forced to work for endless shifts knee-deep in icy, sewage-filled water.
Horrendous condition.
Absolutely dreadful. This led to rampant sickness, injury, and a significantly higher human toll than even direct accidents. The constant need for repairs, the delays that stretched the project timeline for years, and the continuous exhausting battle against the elements pushed the budget far, far beyond what that initial preventative driftway would have ever cost.
So this even cost them far more in the end.
Immensely more. It stands as a stark, cautionary tale. A seemingly small, short-sighted economy can snowball into catastrophic expense, immense human suffering, and profound delays, proving that cheap often ends up being the most expensive option of all.
That's a truly powerful and tragic example of how cutting costs in the short term actually created a far larger and more complex problem down the line. It was that classic trap, isn't it?
Absolutely. Conversely, Brunel himself demonstrated remarkable foresight and a genuine understanding of value when designing the iconic Maidenhead Bridge.
Ah, the railway bridge with the flat arches.
That's the one. Despite cast iron being a popular and often cheaper material for bridges during that era, Brunel chose to use traditional brick arches. His concern was prescient. He feared that the constant vibrations from heavy steam trains, combined with the material's inherent brittleness, could crack the cast iron over time, leading to structural failure.
So he went with the older tech brick because he thought it was more reliable for that specific use.
Exactly. It was a clear, deliberate decision prioritizing long-term reliability and function over a potentially cheaper but significantly riskier alternative. He understood the context and the long-term load on the structure. It wasn't just about the cheapest material, it was about the right material for the job, considering the future stresses.
And his brick arches worked incredibly well, as we know. They've stood for well over a century and a half, still carrying trains today.
They absolutely have, a testament to his engineering judgment. It also underscores an evolving understanding of materials and structural mechanics. The source, Structures, or Why Things Don't Fall Down, notes that cast iron arch bridges are rarely built today, not because the concept is inherently flawed, but because there are now cheaper ways of doing the same job that offer comparable or superior performance.
So better materials or designs came along.
Right. And this distinction highlights the critical importance of material science in truly cost-effective structural design. Understanding that an arch works primarily in compression, while a beam carries tension. Using the right material for the right forces is a key element of delivering both structural integrity and long-term value, balancing innovation with proven reliability.
These historical examples really underscore that the fundamental tension between initial cost and long-term performance, between ingenuity and short-sightedness, is truly a constant in the world of building. It's not a new problem.
Not at all.
But thankfully, while the problems might be old, our tools and methodologies for tackling them are certainly new.
Oh, yeah, exactly.
The problems might be deeply rooted in history, but our toolkit for addressing them has certainly evolved dramatically. So how do modern project managers and builders apply systematic thinking and leverage cutting-edge technology to deliver value in the increasingly complex, interconnected projects of today.
This is where we see a significant evolution, a shift really from relying primarily on individual genius, like Brunel's, to implementing systematic organizational approaches, and often leveraging powerful digital tools, of course.
Makes sense. Systems over individuals to some extent.
Right. Modern methodologies place a strong emphasis on strategic project management as a conduit for value delivery. Effective project management offices, or PMOs, are absolutely central to this. According to the PMBO guide, PMOs are designed to support value delivery. How? By fostering project management capabilities throughout an organization and, crucially, right-sizing processes and governance.
Right-sizing. What does that actually mean in practice?
It means tailoring the level of control, the rules, the paperwork to fit the project. Their overarching goal isn't just to manage tasks, but to achieve high-quality results efficiently, quickly, and effectively. This signifies a move beyond mere task management. It's about embedding value-driven thinking directly into the organizational DNA and operational frameworks of a project.
So PMOs aren't just administrative bodies ticking boxes. They're truly central to making sure value is actually delivered, not just talked about. But how does right-sizing processes and governance actually translate into tangible, on-the-ground benefits for a project? Seems like it could just mean more bureaucracy.
That's a great question and a common concern. But ideally, it's the opposite of bureaucracy. Right-sizing means meticulously tailoring the rules, procedures, and oversight mechanisms to the specific scale, complexity, and inherent risk profile of a given project. Think about it. A small, straightforward office renovation doesn't require the same rigorous, multi-layered oversight and documentation as a multi-billion-dollar infrastructure project involving hundreds of diverse stakeholders and significant environmental impact,
I
right?
always thought that would be overkill.
Exactly. PMOs ensure that the rules of the game are efficient and genuinely effective, preventing bureaucratic bloat that can inevitably slow things down, add unnecessary costs, and stifle innovation. They make sure projects have just enough governance to succeed and not so much that it becomes a cumbersome burden, so it directly improves efficiency and overall cost effectiveness. It's about smart regulation, not over-regulation.
Okay, that makes sense. Tailored control. And you mentioned alignment earlier.
Yes, a core principle for success is the importance of alignment, and it's a constant, active effort. As the PMBOK guide emphasizes, planning activities and artifacts need to remain integrated throughout the project. This means ensuring that the planning for scope and quality requirements consistently aligns with delivery commitments, allocated funds, resource availability, acknowledges project uncertainty, and, most crucially, meets stakeholder needs.
It sounds like keeping a lot of plates spinning at once.
It is. Imagine a symphony orchestra. Every instrument, every section must work in perfect concert. If the strings are playing one tune and the brass another, you have discord, right?
It's chaos.
Exactly. In a project, if the design team is specifying high-end materials while the budget is constrained, or if the construction schedule doesn't account for complex logistics, you get that same discord in the form of delays, rework, and overruns. This integrated approach actively minimizes those missteps and rework, which are massive value detractors.
That concept of integrated planning and alignment makes perfect sense on paper. But in the real world, getting everyone on the same page, especially across different disciplines and organizations, that can be notoriously difficult. Are there specific practices or frameworks that really succeed in fostering that early, deep integration you're talking about?
Absolutely. And this is where some specific methodologies come in. A core principle for success is the importance of alignment, and it's a constant, active effort. Lean practices are an excellent example of methodologies designed to achieve this early integration. They strongly advocate for the involvement of specialist suppliers in design.
Bringing the builders in early, not just handing them the plans.
Exactly. To achieve a more robust system design and proactively prevent issues from arising in the first place. One particularly interesting collaborative exercise mentioned in the Lean Research Guide is schematic design in a day, or SDID.
Design in a day sounds intense.
It is. It's an intense, facilitated workshop bringing together key design, construction, and even operational expertise very early in the design process. The goal is to rapidly explore options, identify potential conflicts, and make informed decisions collectively before things get too locked down.
So you hash out the big issues right at the start.
That's the idea. However, the source notes a challenge here. Contractual restraints can sometimes make this type of deep, early collaboration difficult. Who's liable if a suggestion from a supplier, brought in early, leads to a problem? So it highlights how systemic thinking also needs to extend to contractual frameworks to truly unlock and protect value.
The legal side. Always complicates things.
Doesn't it just? But it's crucial to address.
Sounds like early integrated collaboration is absolutely key. But let's talk about the big technological game changer. Building information modeling, or BIM, it seems to be a huge part of modern value delivery.
It's not just a part, it's really a transformative force. BIM is often narrowly perceived as just a piece of software, but the BIM handbook clarifies that it's fundamentally a human activity that ultimately involves broad process changes in construction.
So it's a way of working, not just a tool.
Precisely. It's a profound shift in how projects are conceived, designed, built, and even operated over their entire life cycle. BIM resolves fundamental representational issues that have plagued architecture and construction geometry for centuries. We move from disparate 2D drawings to an integrated 3D model with embedded data.
And the benefit of that is?
Well, it yields quick payoffs that translate directly into value. Tangible improvements like a significant reduction in drawing errors because everything's linked in one model. You also see improved engineering productivity as designers can iterate and analyze designs more rapidly. And critically, the elimination of design errors based on spatial interferences.
Clash detection, right? Finding where pipes hit beams before you build.
Exactly. Imagine discovering that a major pipe clashes with a structural beam before you've broken ground, rather than midway through construction when it's hugely expensive to fix. BIM saves immense amounts of time, money, and frustration that way.
Those are genuinely massive benefits. Avoiding errors and interferences before anything is even built must save an incredible amount of time, material, and money. It's literally de-risking the entire construction process.
It absolutely is, and the value extends further. BIM also significantly aids in cost estimating by providing takeoff information for components. Because every element in the model is an intelligent object with associated data like dimensions, material type, etc., it can automatically generate quantities of materials.
So counting bricks or measuring pipes automatically.
Pretty much. However, to fully leverage BIM for detailed cost estimation, including the intricacies of labor, installation costs, non-permanent materials like scaffolding or temporary supports, standardization is crucial.
That kind of standardization.
Well, the BIM handbook points out that designers and estimators need to coordinate methods to standardize building components and their attributes for quantity takeoff. For instance, a BIM object might accurately provide the linear feet of a wall, but without further standardization, it won't automatically tell you the linear feet of taping needed for installing sheetrock or the number of fasteners required.
The really granular details.
Exactly. Bridging these data gaps through standardized definitions is the next frontier for maximizing BIM's value in cost management, making the information richer and more universally understood.
So the richer the data embedded in the model, and the more standardized that data is, the more profound and comprehensive the value BIM can deliver. It sounds like a continuous evolution.
It definitely is, and BIM's utility extends to highly complex, time-sensitive scenarios. For example, 4D CAD techniques, which integrate schedule information with the 3D model, adding the dimension of time, were employed for microplanning of a construction operation during the construction of an underground subway station roof in London.
Microplanning.
Yeah. Simulating every step of the erection sequence, down to individual crane lifts and material placements, all to meet an incredibly strict 48-hour time limit for a critical phase of work. This demonstrates how BIM optimizes high-stakes, time-sensitive operations. It allows teams to identify and resolve potential conflicts, resource clashes, or scheduling bottlenecks virtually before any physical work begins.
Preventing costly delays and errors in the real world by rehearsing it digitally.
Exactly. It's like a full dress rehearsal for construction. It takes out so much guesswork and potential for error.
That's incredible. It's literally a full dry run of the construction process before breaking ground.
Are there other systematic approaches that help optimize processes, especially in a proactive way? Maybe less tech-focused?
Certainly. The influential business novel The Goal introduced the theory of constraints, or TOC. Have you come across that?
Vaguely, something about bottlenecks. That's the core idea. TOC is fundamentally about identifying and managing the single biggest limiting factor, the bottleneck, in any process to predict and optimize overall throughput or output. And what's particularly valuable today is that companies are applying TOC concepts not just to fix existing problems,
Which is useful in itself.
right, but they're applying it proactively to the design of new plants and production lines to solve problems before they arise.
Okay, how does that work?
Think about it. Rather than waiting for a production line to start, identifying where things are slowing down, and then having to frantically fix that choke point, you proactively design the entire line to prevent bottlenecks from ever occurring in the first place. You model the flow, predict where the jams might happen based on capacity and dependencies, and then build in the efficiencies from day one.
So rather than waiting for a production line to start and then fixing its bottlenecks, you design the line to prevent them from ever occurring. That's true foresight.
Precisely. It's a profoundly powerful, proactive form of value optimization, saving immense costs and headaches down the line. Designing efficiency in, not bolting it on later.
That makes so much sense. Any other systems like that?
Well, this proactive approach is further reinforced by systems like the Last Planner System, or LPS. This was developed specifically to improve workflow reliability and percent plan complete PPC in construction projects.
Last planner, meaning the foreman or supervisor actually doing the work.
Essentially, yes. LPS is a collaborative planning process that involves those closest to the work, the last planners, in developing weekly work plans. It ensures that tasks are well-defined, sound, sequenced, and sized to performer capabilities before commitments are made.
So making sure everything's actually ready before you promise to do it.
Exactly. It involves checking that all necessary prerequisite work is done, materials are on site, information is available, equipment is ready, everything needed to actually perform the task. By systematically reducing variability and ensuring readiness, LPS significantly improves efficiency and predictability on the ground.
Preventing that common scenario where workers show up ready to go, but something's missing.
Right, preventing the waiting game, which is incredibly wasteful. LPS helps ensure that when people are scheduled to work, they can work productively.
So what does this all mean for our deep dive? We're seeing how this sophisticated blend of technology like BIM and structured thinking like TOC and LPS are allowing for incredible gains in efficiency and quality. This isn't just about managing projects. It's transforming how projects deliver profound, sustained value long before construction even begins. It's about setting things up for success.
That's a great way to put it, proactive value creation.
It all sounds ideal when we're discussing intelligent optimization and leveraging these incredible technologies like BIM and systematic planning. But let's be honest, often the real-world pressure is just to cut, driven by dwindling budgets or rising costs. You know the drill.
Oh, I do. The pressure cooker environment.
Exactly. When does that approach, simple cost-cutting, go disastrously wrong? When does it compromise true, long-term value for a fleeting, short-term saving?
This is such a critical distinction because the relentless pursuit of cheap can, paradoxically, be the most expensive mistake a project can make. We see countless examples where good intentions or simply overwhelming budget pressures, when misapplied, lead directly to compromised value and ultimately far greater expense down the line.
Got any examples?
Well, revisit the anecdote from the book house. Remember Jim, the builder? He's described as pretty worn down by client requests for changes, new vanity tops, new staircase designs, only to be told that Jonathan's been spending it and there isn't any left.
The scope creep versus budget crunch.
Exactly. This isn't a scenario of smart value optimization. It's a stark illustration of aspirations dramatically outstripping an allocated budget. It leads to immense friction, stress, and ultimately compromises that are almost certainly not well thought out or strategically sound. They're just desperate cuts made under pressure.
So the client's vision expands, but the budget remains fixed, or even shrinks, creating a frantic scramble to cut things that might actually be crucial to the quality or long-term satisfaction. That's a recipe for disappointment and conflict for sure.
Absolutely. Another compelling example comes from Shop Class as Soulcraft. The mechanic there describes his lust for thoroughness.
Lust for thoroughness sounds dangerous.
Well, he felt compelled to get to the bottom of things with an oil seal issue on a motorcycle, even if that exhaustive pursuit of perfection was at odds with the world of human concerns in which the bike is situated, where all that matters is that the bike works.
So he wanted perfect, the owner just wanted it fixed.
Pretty much. This highlights a potential and often costly disconnect. Exhaustive technical fixes, while perhaps intellectually satisfying for the mechanic, might inflate costs far beyond the practical value for the owner, where simply getting the bike to function reliably is a priority. Unnecessary thoroughness, when it overshoots the actual functional requirement and the client's practical needs, can erode value from the owner's perspective, making a repair unnecessarily expensive.
That's a powerful point. It's about understanding the actual functional requirement, the good enough point sometimes, and aligning costs to that rather than over-engineering or over-servicing beyond what is truly needed or desired by the person paying the bill.
Precisely. And in construction, this problem is exacerbated by design deficiencies and document shortcomings in project plans. These are common pitfalls.
Mistakes or gaps in the blueprints.
Yeah, or just ambiguity. And as project management and construction notes, unscrupulous contractors might actively exploit these issues by generating lots of change orders.
Ah, the change order game.
Right. Imagine a contractor finding ambiguities or missing details in the architectural drawings. Instead of clarifying them up front, they might just proceed, knowing they can later submit a costly change order for anything that wasn't perfectly specified. Oh, you wanted that type of widget the drawings didn't say, you know.
Yeah, I can see how that happens.
So this demonstrates how poor initial quality and design documentation, which might have happened because someone tried to save a bit on design fees, directly translates to significant cost overruns, delays, and disputes during construction. It dramatically erodes the project's overall value.
It's a vicious cycle where a lack of upfront investment in thorough design leads to much larger, unavoidable expenses later. Penny-wise, pound foolish.
That's the classic phrase for it.
It's fascinating how these examples consistently drive us back to something more profound than just a balance sheet. When we look at these compromises, it really exposes a deeper truth about integrity, the long-term vision, and sometimes even the fundamental functionality of what we're building. It's that tempting illusion of the quick fix that so often creates these costly, unintended consequences.
That's a profound observation. And systems thinking provides a crucial lens here. It teaches us about the counterintuitive behavior of systems.
Counterintuitive how?
Well, attempts to fix a system by pulling a lever in what seems like the right direction, but maybe doing it too hard or in the wrong place, can actually make things worse. Thinking in systems meticulously explains how pulling a lever in the wrong direction can make oscillations worse.
Oscillations, like things swinging back and forth wildly.
Exactly. For example, intuitively, you might think that trying to speed up inventory flow by acting faster, placing bigger orders more often, say, would improve things. But often, if not done systemically, understanding the delays and feedback loops, this can paradoxically worsen oscillations in inventory levels. You end up with either costly overstocking or damaging shortages.
Hey.
Back and forth.
Overcorrecting.
Precisely. This illustrates how reactive, non-systemic cost-cutting, often driven by a desperate desire for quick fixes, can easily worsen overall performance and cost. It creates new problems or exacerbates existing ones within the complex web of a project. You solve one problem, create two more.
It's like trying to put out a fire by throwing gasoline on it without realizing what you're doing. A short-term reaction that makes the long-term problem much worse.
A very apt analogy. The same source, Thinking in Systems, also discusses how growth has costs as well as benefits, and we typically don't count the costs.
How does that apply here?
Well, this broader systems thinking applies directly to projects where short-term cost savings might completely ignore downstream impacts or hidden expenses. For example, choosing a cheaper, lower-quality HVAC system might save upfront capital, right?
Sure, lower initial price tag.
But it could lead to significantly higher energy consumption over years, frequent maintenance issues, costly repairs, and a dramatically shortened useful life, all accruing much greater costs over the building's entire lifespan. We often focus laser-like on the initial investment and completely overlook the total cost of ownership. That cheaper system wasn't really cheaper at all in the long run.
That's a classic one. You see that all the time. Do we have an architectural example of this kind of compromise where financial pressure directly impacted a grand vision, something concrete?
Indeed, a poignant one. Consider the Loggia del Capitaniato in Vicenza, designed by the legendary Renaissance architect Andrea Palladio.
Palladio, okay. Master architect.
Absolutely. But financial pressures forced a compromise on the present form of this magnificent structure. The building, as it stands today, ended up significantly smaller than Palladio's original, more expansive conception.
So they ran out of money mid-project.
Essentially, yes. The source Palladio points out that the inscription celebrating its benefactor starts at the far left of the frieze, subtly implying no further expansion was possible, even though Palladio's grand design may have envisioned a much larger, perhaps five-bay structure instead of the three it has. It's a clear historical instance where budget limitations directly curtail the design's aspiration and scope.
Leading to a smaller, maybe less grand final product than the architect originally envisioned.
Exactly. It's almost a bittersweet realization when you look at it. Imagine Palladio's full majestic vision being cut short, not by a lack of skill or imagination, but by the cold, hard reality of a depleted treasury. It serves as a poignant reminder that architecture isn't just engineering and function, it's also art, and budget compromises can fundamentally diminish that artistic intent.
That's quite sad, actually. And sometimes the compromise isn't just about functionality or sheer size, but about how something looks or feels, isn't it? The aesthetic value, the very soul of a structure, can be chipped away.
Absolutely. The pattern of English building provides a wonderfully illustrative example of this. It describes how thin, monotonously regular slates look particularly ungenerous and unworthy when awkwardly paired with robust red sandstone.
Okay, paint me a picture.
Imagine a magnificent building constructed with solid, rich red sandstone walls conveying strength and timelessness. Then, atop this grandeur, a roof made of the cheapest, thinnest, most uniform slates, laid without nuance or texture, just flat, boring gray.
Ugh, yeah, that sounds jarring.
It creates this visual dissonance, right? It highlights how cost-driven material choices, made without consideration for aesthetic harmony, contextual appropriateness, and overall perceived value, can significantly detract from the overall quality and perception of a building. It's not just about structural soundness. It also needs to feel right for its context and convey a sense of quality that matches its other components.
So the cheap roof makes the expensive walls look worse.
Exactly. It diminishes the entire structure, undermining the value of the more expensive parts and the overall architectural vision. It just looks wrong, off, stingy even.
It's so true. This isn't just about money. It's about integrity, the long-term vision, and sometimes even the basic function and beauty of what we're building. We simply have to look beyond the immediate price tag. So if pure, unthinking cost-cutting is clearly a minefield full of unintended consequences and aesthetic disasters, what's the true path to genuinely getting more for less? How do we build in lasting value, anticipating future needs and embracing innovation rather than just reacting to immediate budget constraints?
The key, I think, is a fundamental shift. Moving towards holistic, value-based thinking that's integrated seamlessly throughout the entire project lifecycle, from the very first idea to long-term operation and even eventual deconstruction.
Holistic thinking. Okay, what does that look like in practice?
Well, one powerful strategy, as introduced in How Buildings Learn, is designing for adaptability and future-proofing. This concept isn't about clairvoyantly predicting the future because, let's face it, that's impossible.
Right, no crystal balls.
No crystal balls. But it's about creating forgiving buildings, structures that can gracefully adapt to unforeseeably changing conditions. The goal, as the book puts it, is to ensure that no matter what happens, you always have maneuvering room. This prevents costly obsolescence or difficult, expensive retrofits down the line when needs inevitably change.
That's a profound concept, building in resilience to the unknown, building in flexibility. How does one actually translate that into practical design and construction decisions?
One remarkably effective way is by postponing many design decisions and leaving them to the eventual users. This might sound counterintuitive to traditional, highly prescriptive design where every detail is locked down early.
Yeah, seems like kicking the can down the road.
It can seem like that, but it offers immense flexibility and long-term value. Think of modern shelling core office buildings. The developer builds the primary structure, the skin, the main systems, the shell and core. But the interior fit-out, the specific layout, the finishes, that's left for the tenants.
Right, so each tenant customizes their own space.
Exactly. This allows for customized floor plans, technology integration, and aesthetics as needs evolve over decades. It significantly extends a building's useful life and enhances its value over time for a diverse range of occupants. The building can have many lives.
Instead of being stuck with an outdated layout from 30 years ago.
Precisely. The source also introduces the concept of creating raw parts that could be finished later in response to accumulating revenue and to all that would be learned from use of the cooked parts.
Raw parts, cooked parts. Explain that.
Think of it as intelligent, phased staging of investment. You build the essential cooked parts, first the structure, the basic systems. Then the raw parts, maybe unfinished floors or areas designed for later expansion, can be completed as money becomes available and as you learn how the initial parts are actually being used.
Ah, so you learn from experience before committing more funds.
Exactly. It optimizes financial outlay against learned needs. You don't overinvest in features that might change, become obsolete, or prove unnecessary once the building is actually in use. It's a pragmatic, responsive approach. Less waste, more targeted investment.
So you build the essential adaptable structure, and then the details can be filled in later as needs become clearer, making it a more responsive and less wasteful investment. That makes a lot of sense.
It does. And sometimes the simplest design principles can yield the greatest long-term adaptability. How Buildings Learn gives the straightforward advice to be square for building shapes.
Be square, like literally rectangular.
Yes. While architects might at times groan at the thought of boxy and simple forms, the book argues that the only configuration of space that grows well and subdivides well and is really efficient to use is the rectangle.
Huh, why is that?
Because it prioritizes functional efficiency, ease of maintenance, and future adaptability over complex, potentially expensive or inflexible forms, think curves, odd angles that become a nuisance to maintain and hard to change as needs shift over the building's life. Rectangles are just easier to divide up, furnish, and reconfigure.
So sometimes simple is smartest for the long haul. Practical elegance.
Exactly. It's about enduring practicality over fleeting stylistic trends that might look cool now but become a headache later.
That's a powerful lesson. Beyond adaptability, how does modern construction think about value over the entire lifespan of a project, not just the initial build? We touched on the HVAC example earlier.
Right. This brings us squarely to lifecycle thinking and sustainable value, a concept that has gained immense importance, thankfully. Sustainable construction emphasizes things like resource-conscious design and closing materials loops as key objectives.
Closing material loops, like recycling.
Yes, but more profoundly. It means designing products and buildings that are inherently easily disassembled at the end of their life. Using materials that are not just recyclable, but worthy of recycling, meaning they retain value. And critically, using materials that are inherently non-toxic. It's about moving from a linear take, make, dispose model.
Where everything ends up in landfill.
Right, to a circular economy, keeping materials in productive use for as long as possible rather than consigning them to landfills as waste. Designing for disassembly and reuse from day one.
This sounds like a much broader, more encompassing definition of cost and value, incorporating environmental and long-term societal impacts alongside financial ones.
It absolutely is. It compels us to move beyond simply the initial construction cost and to meticulously evaluate the life cycle impacts of all materials and systems. This includes factors such as energy consumption and emissions during resource extraction, transportation, product manufacturing, and installation during construction. Operational impacts throughout the building's life, like energy use, water use, maintenance, and the effects of disposal at the end of its useful life. This holistic view truly defines long-term value.
It's a much bigger equation.
Much bigger. For instance, Fundamentals of Building Construction provides a concrete example related to wall insulation. It shows how a 2x4 framed wall with batt insulation plus 1 inch of rigid foam on the outside can achieve a similar R value or insulating capacity to a much thicker 2x6 wall filled only with batt insulation. But crucially, the 2x4 with rigid foam also reduces heat loss due to thermal bridging at solid framing members.
Thermal bridging, that's where heat escapes through the wood studs.
Right. Exactly. The continuous layer of foam breaks that bridge. So this is a nuanced, intelligent choice. It offers not just comparable insulation value, but actually improved energy efficiency by reducing that bridging, leading to significant long-term operational savings on heating and cooling. It delivers far more value over the building's decades of use, potentially with less wood used, too.
That's a perfect example of a smart choice that offers a deeper, more enduring value than a simple material comparison. It highlights that true value often lies in the hidden efficiencies, the system's thinking.
Precisely. It's about understanding how components work together.
What about the role of innovation and creativity in all of this? Is it just about smart systems and careful analysis, or does human ingenuity still have a starring role in finding these value-driven solutions?
Oh, human ingenuity remains indispensable, arguably more so than ever. The existential pleasures of engineering reminds us beautifully that good engineering depends upon leaps of imagination as well as painstaking care.
I like that. Imagination and care.
Right. Genuine value creation, the ability to truly get more for less in a meaningful sense, often comes from creative solutions and ingenious breakthroughs, not just reactive adjustments or incremental improvements. It's about challenging assumptions, asking, why do we do it this way? And finding entirely new ways to solve old problems.
Like the Greeks finding a workaround for flawed marble.
Exactly. Or connecting back to the theory of constraints, TOC, we discussed earlier, applying its concepts proactively to the design of new plants and production lines. That's not just analysis, it's a creative act. It's a powerful testament to this idea. It's a proactive, imaginative way to solve problems before they arise, preventing costly inefficiencies and bottlenecks from the outset by imagining the future flow, identifying potential weaknesses, and literally engineering them out of existence from the very beginning.
Designing the problems away before they happen.
That's innovation at its finest, embedding value from the very inception of a project through creative foresight.
It's truly fascinating. This isn't just about cost-cutting then. Not at all. It's about a fundamental mindset shift, a holistic way of thinking about projects from their very inception. It's a way of designing, managing, and building that genuinely delivers more for less in the most meaningful and enduring sense. It's not about cutting corners, but about building smarter, with profound foresight and a broader, more integrated understanding of every impact a project will have.
Couldn't agree more. It's about intelligence, collaboration, and a long-term view.
What an incredible deep dive this has been. Seriously, we've journeyed from the pragmatic wisdom of ancient Greek builders and the economic structural systems of the Romans.
Masters of scale and efficiency.
Right. Through the stark, hard-learned lessons of the industrial age regarding short-sighted savings, poor Brunel's father.
A tough lesson there.
Right up to our modern era of sophisticated digital tools like BIM and sustainable lifecycle thinking. What has become abundantly clear, at least to me, is that the pursuit of value in any project is an ongoing dynamic dialogue. It's between aspiration and practicality, between desired quality and financial cost.
It's always a balancing act.
Always. And true, more for less, isn't about arbitrarily desperate cuts made in a panic. It's about intelligent, integrated design and management that deeply understands the complex, long-term implications of every single decision, no matter how small it seems at the time.
That's really the heart of it. And what's truly fascinating here is how consistently, across millennia and vastly different scales of projects, the most successful and enduring outcomes arise from a profound understanding of core function.
What does it really need to do?
Exactly. Plus, a creative and ingenious approach to resourcefulness, using what you have wisely and an unwavering commitment to long-term impact.
Not just the ribbon-cutting ceremony.
Definitely not. Whether it was Greek architects ingeniously adapting materials to their inherent limitations, or modern engineers leveraging building information modeling for pre-construction problem solving, the core principle remains the same. Thoughtful, integrated design and process optimization consistently delivers superior and lasting value. If we connect this to the bigger picture, it's really about moving beyond the simplistic, often misleading notion of cheap to embracing the profound compounding impact of smart on our built environment, our resources, and indeed our society as a whole. It challenges us to redefine economy not merely as the lowest initial cost, but as the maximum long-term benefit and sustainable impact for the resources and effort invested.
That's a powerful reframing. Smart versus cheap. Long-term value versus short-term price. Right. Absolutely. So here's something for you, our listeners, to think about. As you go about your day, perhaps consider a product or a building in your own life. Something that you initially thought was too expensive, maybe you hesitated buying it, but it's unequivocally proved its worth over time. Through its exceptional quality, its robust functionality, or maybe its remarkable adaptability.
Something that just lasted or worked really well.
Right. What hidden value did it deliver, perhaps, in terms of peace of mind, reduced maintenance costs, enduring satisfaction, maybe even just pure joy in using it that a cheaper, immediate alternative would simply not have provided? Worth thinking about.
Definitely.
We'll catch you next time here on The Deep Dive.